full name of Aster is the Android System Testing Environment and Runtime, which is created by the Zero-Act Lab originally. But since it used the monkey runner engine to do the UI control, that we can't use it to control the UI in the remote side, like in our Linaro, in the Lava Lab. We can't use this Aster tool to control the Android device. So I add some changes on it and make it possible. Here are some new features that I did into the Aster with my change. First, yes, is to add support for remote device. But now only the access via SSH protocol is supported now. Others do not support yet. Second, add support to input the serial number when we started the tool. This makes us run two Aster instances at one local site, at one laptop. Third one, I add a feature to display the log kite and kernel message for the device, and this will help us to check what happens on the device side. Also, I did some more actions to make we can use the Aster tool more easily and more functions. Last one is make it Eclipse product, so that with one import step we can do the development. Here describes the in-depth about how to control the remote device with this Aster tool. First, we need to make add the Aster ADB host entry in the .ssh config file. Second, we need to copy our the public key of our host to the SSH side. This one is the entry I added in my .ssh config file. I use this Aster ADB host to access the Lava Lab. Second, when you start the Aster tool, we need to select the AD type, the SSH as the ADB type. Like here. And then you input the serial number that you want to control, and wait until the home screen displayed on the Aster window. There are some dependencies for using this Aster tool. First, on the device side, we need the ADB share input command and the ADB share screen type command works. so we need the ADB connection created on the our host or on the SSH host side. On the host side, the machine we run this Aster tool. We need to install the OpenCV library, and also it depends on the Java. We need to install Java. Some features still not support with my change. First is about the monkey runner. This was supported originally, but I make it broke. Second, cannot edit the action the action or the script we record before. So this may make this limit may make it difficult to or not easy to reuse a script if there are some problems, UI change or command information change on the device side. Still not support for the interaction between two or more devices. Like when we test a chat tool, instant message tool, that may not possible for now. Okay, and another limit is that I only test this Aster tool on my Ubuntu 14.04 platform, not test on other platform, but it should be, or we can make it possible to run on other platforms like Windows. For the actions, among the actions that I did, there is a call action which is used to run a script we recorded before, but that not works very well. We will improve it in the later. Okay. Following up some steps about or some information about for the development. First, to develop it with Eclipse, just git call the repository and import the project. Then run the run or debug it as the Java application and use the Aster main class as the main class. Then you will see the Aster window that up. In the repository there is a build.xml file that is used by the unt command. We can use that command to generate the distributable file. Here is an image about the Aster window. Here are some action, UI action or UI classes that are used for either action or either other options. This window is used to display or update the display for the screen. Here is a part that we can play the entire script or debug it with the start button. Here are some status bar will be used to output some debug message or kernel message or the log catch message. In the source, there are some concepts like Aster command, Aster option, device for Aster and UI components. So the Aster command, that's the simple command that we used to generate the action, like the ADB share action, which we can input ADB share command and run ADB share command on the device, or others like this call action. After option is the simple class to like define some options or some options for get the input from user interface. When like for the ADB share command, we will get the share command user input, and that will need one after operation subclass. This device for Aster is a super abstract class that used for different ADB types. Now, there are only the local ADB type and SSH ADB type have been implemented. To add a new action, there are only two things need to be done. First is add one entry in the Aster command class. Second is to implement the action class here, like install APK or ADB share class. You can use when we add a new action, we can use other class as simple. It's very similar. Here is how to add a new remote type. This example is about add the support for SSH protocol. First, add the entry as the initialization in the device for Aster classes, like here, and add the new type remote type class implementation for the new remote type. There are only small abstract method needed to implement. Here only the get ADB serial array list and get a screenshot path needed to implement. here is a video I recorded before. Let's run the Aster tool with the next name device. Here you can see here are the action list which we want to run. And this is the screen displayed on in the Aster tool. And this is the device, next name device. This I mainly changed this changed for doing the remote control via SSH. So there may be there should be much problems to use build it. But this in the future we will improve that to make it more easy and more stable. Okay. This script this script is used to install one JBench benchmark application and run it. After finish got the result, uninstall it. The script is that's what the script. I have a video for the do operation on the remote side, but since the device since the since I use the SSH protocol and access to the remote side, the network speed is not very good, and so the change here is very slow. Here is just do the init and home action, which is to do some reparation and go to the home for running a new script. And this touch is waiting for the device to go to the home screen, but since the network speed is not good, so it will take a long time. Okay, here the home screen displayed. And here after the touch action, it shows the application status. Here, the GBench application. Got the result. This is where the speed is very, or update is very slow, but anyway, it can help us to access the remote device. Okay, that's all about this Aster introduction.
I have a question. What is the purpose of doing that? Because there are already tools that allow you to do it. There are already existing tools that do the same stuff.
Existing tool.
Yeah, there are at least, I know at least 2 tools that do the same.
Oh.
There is AirDroid, which allows you to access the remote devices, and you don't have to care about like the connection basically. And there is Android View Client, which allows you to record and replay the test case, like test do the test cases. So like what's the purpose actually of doing that, doing the same stuff that is already implemented and don't have the dependencies and the limitations that you have here? So why invest time in doing stuff while it's already done and you just take it and use it?
At the beginning, I didn't actually I didn't find a tool and do the remote UI control. Like for our for our problem, we want to use I want to control the Juno device in the Lava lab.
Yeah, there's an app called AirDroid which allows you to do so.
Yeah, but this is over SSH and ADB. It's more of controlling the UI.
Yeah, this is what AirDroid does.
Will we have the flexibility? I'm not sure. Does it have the flexibility that I'll be able to access it from my home?
Yeah, that's exactly what it does.
Which app you say?
AirDroid.
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 So how do we say it? Is it open source or?
It's not open.
That's based on the web server, right?
Yep.
Yeah. For that tool, the display is not actually about like the display of the Android device. That's actually it has the tool has a screen like our Android home, not the not the home of Android.
Yeah, I mean, AirDroid, you're able to access the content of the device and take screenshots kind of things. Here, you can actually remote interact.
With Android UI client that I showed yesterday, you can do the same stuff, and you don't have the dependencies, and you don't have to wait for the screen read, actually.
Yeah, I mean, if we can hook it up in Lava. So
Yeah, the setup would be exactly the same. So you basically create an SSH tunnel like you're doing, and then you run the script. So it's totally the same, except for the fact that you don't have to do the OCR on the screenshot.
Actually, I'm not sure, but I'm just checking AirDroid. It just allows access.
Now
it has its own interface.
But now we're talking about different stuff.
Huh?
Now I'm talking about different stuff. So the second tool.
Android view client.
Android view client.
Okay. That I need to check.
It's already implemented both these.
So it's already implements all the actions on the device you can take. It already implements the screenshot, and it doesn't depend on the actual screen. So it depends on the UI automator. It's a different approach to the same problem. So it doesn't depend on the screenshot. It depends on the structure of the UI, which you get from the UI automator. So it's way faster because you don't need a screenshot.
What's the second one again? Sorry.
Android view client.
I will try that too. That's all.
So what I'm trying to say is that you might not need your tool to perform the same exact stuff and focus on the thing that you have to do, not on the tool.
Oh yes, but at the first I didn't find the proper.
Sure.
tool
Yeah,
for
yeah,
me.
I know.
So
It's like,
I changed it.
but you listed some problems that you have, which this tool already solves. So you can connect to multiple devices at once. You don't depend on the OpenCV because you don't do the OCR actually. In some cases there might be problems like we discussed yesterday. So if when the benchmark displays its score as an image, then this is like the only case when you have a problem. But in all other cases there is no problem. And the connection method to the lab is exactly the same. So you do the SSH, tunnel the ADB ADB connection, and then you do the ADB to the device.
Oh yes, that's the one what I want to
But
know.
it's exactly the same you're doing, but you're doing it in the Java code, while you with Android view client you just set up SSH tunnel. That's it.
I don't use this on Lava. Just access the web on Lava. Okay, thank you.
Okay, so the second part of the session is about build system modifications we've made to make it easier to work with other AOSP-based projects. What we did before, essentially before the update to Android 5, pretty much the obvious thing to do. All our work is committed to Linaro branches on android.git.linaro.org, and when a new upstream release happens, we rebased it. That worked well in some regards, like very easy for us to check out an up-to-date repository, just reposing. No additional tools required, and it essentially followed the same workflow that the upstream people are using to maintain their repositories. But that approach also had a couple of drawbacks. Like it was hard to keep track of what patches were upstreamed, what patches were submitted upstream and not yet accepted, and what patches we never even tried to submit. And it was also hard for other projects, like any other AOSP-derived open source projects or the members' internal product trees, or anything to determine what patches we are applying, to determine if there's anything they need, anything they want to pull, any parts they want to leave out, or to determine any interdependencies between the patches. So one of the goals in reworking our approach was knowing immediately where our builds are different from upstream, and make sure that all patches that are interesting to upstream have been submitted upstream. And one thing we realized is we are using Gerrit for code review anyway, and so does AOSP. So we were wondering if we could just pull patches directly from Gerrit, regardless of whether or not they had been reviewed yet, or whether or not their status is accepted or maybe even rejected. And by adding a couple of scripts, we could do that. So now we have a script called apply that takes patch from upstream Gerrit and applies it into a repository. We just say, for example, apply Bionic 109026/1. This will apply the patch to Bionic with this submission ID in revision 1 that we submitted to Gerrit before, regardless of whether it is still in review, whether it has already been accepted, or whether it has been rejected. And another nice thing about this is if upstream applies the patch, applying it again will fail and shows us that it's safe to remove the patch from the list and forget about it forever. And also, if upstream made any modifications that conflict with it, we'll see immediately, okay, problem with this patch, we have to rebase it and submit a new revision. Then another goal we tried to follow is better documentation for patches we are just applying locally. Like we don't generally submit patches that just allow hardware that upstream isn't interested in to work. So the apply script also takes another parameter, --Linaro, that sends it to our Gerrit instead of AOSP's to pull patches from. Otherwise it works exactly the same. And a possible future feature would be allowing to pull patches from other repositories like CyanogenMod or Replicant or whatever. We might start a project at some point to determine if they have any patches that are used with. Yeah, John?
I was going to say one thing.
the amount of information that you're providing in the arguments there, I feel like it approaches the URL for the Gerrit repo. Is there any way you could just use the Gerrit URL to the commit in order to replace that, and that way you could do it for any Gerrit or any Gerrit install?
Yes.
Okay. I just
Essentially, the information is the same that is included in the Gerrit URLs, but this is actually a little more compressed. So the apply script already takes the URL if you use apply -- server and then just give it the URL. And if you just want it to be more readable, especially when you're only pulling from AOSP Gerrit, you can use this syntax.
Yeah, it's more for the readability to understand which project is getting affected for the members. If you just
Okay.
give it, yeah.
Yeah, I did.
And I mean, we could probably even go a step further and leave out the project to which it's being applied and try to fetch that from the Gerrit URL, but that would involve parsing HTML code, and newer versions of Gerrit might change the way they output it, and so it would be a little fragile. So probably better to keep the information there. Another thing is the cherry pick script, which we also added to the toolset. Essentially, that goes into the repository, pulls the remote branches in, and cherry picks a branch for a commit from a different branch. So this is, for example, useful if we are already applying a patch on master and we want to backport it to 502 where it hasn't been applied yet. Then we just use the cherry pick command instead of any apply command to pull that in. So what about extra trees? Obviously with anything that just pulls a patch submission from Gerrit, we cannot create new directories like device, Linaro, HKG or whatever. Actually, it turns out repo has a feature for this that is not very well known but very useful. It's local manifests. The way this works is inside the .repo directory, we create another directory, local manifests, and pull the additional manifest files in there. We have a separate Git repository that just contains those files. When local manifests are present, the repository is checked out from the upstream manifest just as if we didn't have any local modifications. And then it looks at the local manifest files to decide what it needs to modify, what additional trees it needs to pull in, what it can leave out. So this is the syntax of an example. It looks just like a regular Android manifest. XML opener manifest, definition of remotes. Then here we are putting in support for extra devices by just adding another project. One thing that is new in local manifests is remove project. That we can get rid of a project that has been checked out in the regular manifest. For example, to replace it with something else. In this example, we removed the libjpeg implementation from AOSP and instead pull in libjpeg turbo at the same location. Okay. Do you have any questions or feature requests? Or yeah.
So I think I see how cool this is. I was kind of curious. The applies, if you maybe could talk a little more explicit about how you're actually using it to build your trees, or it's that aspect. I get that there's a tool that lets you fetch all these things to build a tree, but is that how the Linaro Gerrit trees are being built?
Yes.
Okay.
So essentially we still do the repo checkout as before.
Yeah.
And then
One additional thing is that once you do repo init, you go to dot repo folder and then git clone this local manifest. That's the additional step compared to what we have, the steps what we have for building AOSP code base. You do a repo init, get into repo folder, we then clone this local manifest in the place, then we do the repo sync, and you can do launch and then make.
But I mean, the apply tool looks really slick to me.
Yes, yes. Can you
Yes.
do you want to go to the URL on the where we host these scripts? Yeah, the Git repository. Yeah.
Yeah, so here we have a couple of different patch sets. Like this is what we used to apply to get plain support, but now this is obsolete because all the patches have been upstreamed.
So just in the pipeline, this is all done on the client end, not done before you pushed in your server, right? So this is when somebody's checking out the tree. This is all done after
yeah.
the fact.
Yeah.
After sync.
Yes, yeah. After repo sync, they'll have to just run this script once.
Yes, and here you can see that it's also quite easy to document, just add a comment before it and then apply. And another nice thing about this is that if someone else wants to pull in some patches, they can just copy those lines and run the same script on top of a modified tree. For example, if a member wants to pull in some of our modifications on top of their own modified product tree or whatever, chances are this will just work. They might have to rebase a couple of patches, but in general, it should work.
I've got another question, but I want to give anyone else a chance to talk. So I guess two aspects was one is that this makes it seem like maybe as a policy change are we now submitting all of our work to AOSP as the default like source?
Yes, that's the idea.
Okay. And then the second was has the apply script been submitted to AOSP?
No, I don't think they have any interest in that.
Okay. This seems really slick. I mean, it's sort of like a neat, almost quilt-like tool for Android. So I think this could be
Yeah, we
definitely
could try
widely
to
used.
actually submit it, but I'm not completely sure where in the repository it should go because maybe in the repo repository as a separate tool or so.
Well, I mean, just even I know when after I've had a repo sync, if I want to check out specific commits to do testing of stuff that people have submitted, it's kind of a little futzy because you got to go into the exact tree and then you run the little script
Right.
that's in the Gerrit review.
line.
And this seems like it has a nice global sense where I can just say, repo sync, apply these three things that I know I want to test, and just get going in the build, and that would be really nice. So I think almost maybe even applying it to repo or having the same functionality added to the repo script would be very cool too. I don't know. This seems really very, very awesome.
Yeah, we can try to submit it. Right now it just lives in our own repositories, but we can try to submit it. Actually, my first thought before coming up with the supply script was just extending repo to allow an extra tag that would say pull in this patch. But creating that script was quite a bit easier, and there's a good chance it would never be accepted upstream because they don't really want people to build from modified trees. So we'll have to see if they'll accept the scripts. Anything else? Okay, apparently not, which leaves us 5 minutes to go to Amit's session.